Hello. The purpose of this video is to discuss the liquid-liquid extraction experiments that are part of our senior unit operations lab. We have two liquid extraction experiments that are part of this course. The one I'm going to focus on is our reciprocating plate extraction unit, which is shown behind me. This one involves vertically oscillating impellers or stages. Next, I'll really briefly show you some of the differences that exist in the York-Scheibel unit, which is shown over here. You can't see in the video. That one involves rotational stages. Okay, so in our lab, what we're going to do is we're going to use water as a solvent, and we'll use that to extract acetic acid from an acetic acid MIBK organic mixture. Okay, this isn't how it would be done in industry. Industry would do the opposite, but we do things here in order to minimize waste produced during the system. Okay, so essentially what we're going to do as part of this experiment is we're going to send in our organic mixture at the bottom of the column. We'll send the organic mixture at the bottom of the column. We'll feed in water at the top of the column. Okay, and then we'll do a couple things to establish steady state, get all the settings at our target inputs. Once equilibrium is achieved, we'll make a couple measurements, and then that'll allow us to collect the data that we need to do our analysis. We'll come back to some of these things a little later. Okay, but let me talk a little bit about how we control the feed to the system. Okay, so we feed the MIBK to the system. So we have a feed line which will go into our carboy feed, which I'll discuss in a few minutes. Okay, the feed of the solution is controlled using a pump down here. The controls to the pump are shown on this control panel here. We can see what the flow rate is using this flow meter as it's labeled acetic acid MIBK mixture. The feed of water, or water comes from us from the city, so we control the feed of water using a flow meter valve. And the flow rate of water will be shown on this flow meter here. Now, as part of your experiment, you may need to calibrate, or at least verify the calibration of either one of these flow meters. Now, this can be done by changing either one of these, three-way valves to calibrate. When these valves are set on calibrate, the respective solution will come out of one of these lines here, and they're both labeled so you'll know whether or not you're measuring the water or the MIBK acetic acid. Either of those flow rates can be measured using the bucket and scale method. Okay, so as I said, before we do anything, we're going to need to make a mixture of acetic acid and MIBK, and that can be done over there. The materials you'll need to make your feed solution can be found in this cabinet over here. Alright, so let's start with this. This is our liquid-liquid recycle, and what this includes is some MIBK and acetic acid, and this would be recycled that has come from a previous experiment. Okay, so likely this is going to be a mixture of MIBK that has had a lot of the acetic acid removed during the experiment, which is what you're going to be doing today or as part of your lab. Okay, so you'll have to first dispense some solution from this storage tank or from this drum into a carboy, and you'll do that using one of those hand pumps that's shown over there in the corner. Okay, now it's important that you pull off from the top of the liquid because there's probably going to be some water in here that was contaminants from previous experiments. Okay, so make sure you're pulling off the top. Your goal is to fill a carboy. We have various carboys around in the lab, up to about 80%. Once you fill the carboy up to 80%, you'll need to determine what the acetic acid concentration is. You can determine that using titration. So we provide you procedures to do this titration, and you can follow that and use that to outline what you're going to be doing in your lab. Now it's important to note that your prelim or your procedure cannot reference any of these procedures that we provide to you. You need to tell us clearly what you're going to be able to, or what you're going to be doing in order to determine what the concentration of acetic acid is in these tanks. Okay, so once you now know this acetic acid, as determined by the titration, you'll have to do a simple mass balance to determine how much acetic acid is needed to get your feed to the target concentration. again, these are fairly simple 2110 type material balances, but just take your time. A lot of people mess these up, and as a senior, you don't want to do that. Okay, you can, once you know how much acetic acid, you can pull it off using this system. I should note, which I haven't done already, is it's not so important how much solution you meter out initially. You're going to be putting this into a carboy. But keep in mind that you're going to want to know the starting weight of the carboy so that you can know how much mass of this mixture was added to the unit, and then you can easily measure how much acetic acid you're adding to the unit or to the carboy later on. Also, as part of this lab, we allow you to use 3 carboys per experiment. You'll need 1 carboy for your feed, which you'll use that day in lab. You'll use another carboy for your raffinate, so that'll collect the organic phase coming off the top of the column. And then we decided to give you another carboy, and by using the 3rd carboy, what you can do is while you're running the experiment in the lab on the first day, you can prepare the feed solution that you'll use in the lab on the next day. So that should save you a little bit of time and allow you to spend your time more, or to collect better or more data that's needed for your analysis. After adding the acetic acid to the MIBK acetic acid mixture to make your target concentration, you'll need to mix it. And you can do that using our very sophisticated pneumatic mixer. Now, be sure to mix the solution. It's kind of fun, so just be careful. Okay, so now I want to talk a little bit about what you need to do in order to collect data, or useful data for this experiment. Okay, like we discussed a little bit earlier, first what you're going to need to do is establish the water flow rate to fill the column. Okay, and I don't know if you can see it at this angle, but you're going to want to fill the column about to the water, fill the column with water about to the water entry point at the top of the column. Okay, next you can establish a flow of organic phase. So the organic phase is going to come in at the bottom. It's going to travel up through the water, and eventually it's going to form a phase above the water at the top of the column. So there's a few important points you want to consider. An important thing is really you don't want any water coming down the raffinate, which is the topmost exit on the system. The second thing you want to consider, or the second thing you want to be aware of is as you're running the experiment, if your flow rates are too high or your agitation speed is too high, it can cause phases to form inside the column, and that's essentially going to prevent your column from separating, going to prevent mass transfer, or prevent the separation that you're trying to achieve. Okay, so with water fed to the column, with organic phase, or water fed to the top, organic phase to the bottom, we'll also need to turn on the agitator. So the agitator can be turned on using this switch right here. And the speed of the agitator is set by changing this valve. Okay, we'll need to see the technician we have a laser tachometer that can be used. There's some reflective tape up on the motor for the agitator. The laser can be shined on in order to determine what the speed of the system is. So now, lastly, while I'm at this angle, I just want to point out a valve at the bottom of the system. So the water is going to exit through the bottom of the column down here. And there's also a sample port. So this sample port down here can be used to collect the water to use for sampling, to determine the concentration, etc. The rest of the water is going to go out the drain. Now you want to be careful to not let the organic, later on when we drain the column, not let the organic exit through the drain. Hello down there. Yes, this is still me. I'm just up at the top of the column. Okay, so now that we've established flow in the column, both with the water phase and the organic phase, we're going to need to establish what's called hydraulic steady state. Okay, so we can, with the flow of water and organic, there is going to be an interface between those two phases that's going to exist somewhere in this column. Our goal is to have that interface exist between the water entry point and the raffinate exit point up at the top of the column. The reason for that is because we want only organic phase to come out at the top. And if we have water coming in on top of the organic phase, we're going to actually prevent mixing in the system, or prevent mass transfer. Okay, so we have a blue tape and a little bit of line up here. So in order to establish that hydraulic steady state, someone in your group is going to need to hang out here and turn this valve. So this valve right here is going to control the water flow at the exit. So by controlling the water flowing out, it's going to move this interface up or down. So you'll need to change this valve position in order to get the interface to occur right about up here. Okay, so once the hydraulic steady state has been achieved, the next thing that you'll need to wait for is for the concentration steady state, or the composition steady state to achieve. Now, there's a pH meter that's on the water exit at the bottom of the column, which I previously showed you, and that pH will show up on the display, which I believe you can see at the bottom right-hand side of your screen, if I have my orientation right. At the bottom of your screen, you'll see a display that shows the pH. Once that pH becomes constant, and this interface level becomes constant, you're at steady state, and you can start taking some measurements. Okay, congratulations, you've reached steady state. Now we can collect the data that's going to be used in the analysis. You're going to need to collect a variety of data. Okay, since you'll know the flow rate of the water entering and the organic phase entering, you'll have that information already. You can measure the flow rate of the raffinate coming out of the top of the column, for all this line over here. You can do bucketing scale. So this line during the experiment should be set up in a collection carboy. But in order to determine the flow rate, you can do bucketing scale to measure how much volume you collected, or how much mass you collect at any given point in time. Okay. In addition, you have a pH probe that's connected to the water outlet, and this will give you the pH of the system, which can tell you the concentration. Now, you don't really know if this is calibrated or not, so this isn't necessarily trustworthy data. So because of that, what you'll need to do is you'll need to pull off a sample of the outlet water here, and you can perform a titration, which can help you identify what the concentration of that stream is coming out. Also, the raffinate stream that I showed you previously, in addition to determining the flow rate of that stream, you'll need to do a titration on that stream as well in order to determine the composition. Okay, once you've determined this information, you should be good to go and ready to do some analysis. All right, finally I want to talk a little bit about shutdown, because shutdown is important in this case. What we want to do primarily is avoid contamination, and then we want to avoid creating waste. Okay, so we don't really want to put water into the raffinate line. So the first thing we'll want to do is we'll want to turn off the feed. We'll turn off the organic feed, we'll turn off the water feed so the water doesn't push up into that line. Okay? The next thing that we'll do is we'll open the water exit so that we drain the water in the column. Okay, note that there's an organic phase at the top. So we'll drain the water that's in the column and keep that organic phase. We'll watch the organic phase as it comes down. When we can barely see that interface with the organic phase, we'll want to stop. Okay, close the valve or close the exit valve, and then take the remaining organic out of the sample port here. By taking the organic out of here, we'll prevent organic going into the drain system. All right, so that's all I have. I'll be able to take questions for you later. At the end of this video, I'll give you a quote-unquote 3D tutorial or view of the experiment so you can see some of the things behind it a little bit closer in more detail. Okay, but before I do that, I'm going to talk to you about a couple differences associated with the York-Scheibel extraction unit. Hello, it's me again. You're probably noticing the scenery looks a little bit different. Don't worry, I'm just at the top of the York-Scheibel extraction unit. So this unit is, the experiment is done very similar to the one I just went through with you, but it has a couple differences. These stages inside here are going to rotate within the column, and in order to have that rotation occur, we're going to need to connect the motor to the top of the column. All right, so that can be done using this, band up here at the top. It looks like a big O-ring. Okay, so you want to make sure that this O-ring is contacting the motor, which is behind this plate. We'll just want to put this band at the top of the column so that the motor is going to turn the shaft inside the unit. Okay, so once that's connected, the speed and the power and the speed are controlled using an interface down here. You can just switch on the column and you can adjust the knob in order to change the speed. It's really the main difference. Everything else is fairly similar. Again, I'll give you a quote-unquote 3D tutorial of this unit so you can see a little bit behind it at the conclusion of this video. So good luck. Let me know if you have any questions, and look forward to doing the experiment with you. So as promised, here is our 3D virtual tour of the liquid-liquid extraction experiment number 2 using reciprocating plates. So here we see in front of us the column, starting at the base, going all the way up to the top. You see the water inlet line, that's the lower line, and the raffinate line, the organic phase coming out, going to be up the top. Okay, we'll start over here with the controls. So you can see we have controls for the pump, we have the display for the pH meter, and we also have the measurements of the flow rate for both the water and the acetic acid MIBK mixture. Everything's clearly labeled. Again, if you want to be running your experiment or calibration, you can change the three-way valves accordingly. As we move around to the back, you can see how things are connected. You'll probably want to look closely here before you do your procedure so you can follow the lines, make sure you understand what the three-way valves are doing in the system. Okay, we can see the main supply valve for the water feeding the system, filter, etc. Looking down at the bottom of the column, there's a couple important things to note down here. The big blue thing in front of us is the pH probe. It's going to measure the pH of the water coming out of the bottom of the column. We have a sampling port that can be used to take a sample of the water in order to determine the composition. Some viewing glasses down at the bottom as well. As we move up to the column, we'll see the valve that we're going to be using to control the interface between the organic and the aqueous phase is shown here. This is the valve that has the really long stem that goes up towards the top of the column. What you'll need to do in the experiment is you'll need to adjust this valve while looking at the liquid organic interface, which should exist between the water inlet line and the organic outlet line, or the raffinate, up at the top. The pump shown up the top is controlled using this knob down here. I'm going to go ahead and walk up to the top of the column, and we can take a look at the pump system, or we can look at the motor. It's going to run the column. There you can see the motor. It's going to rotate. The shaft up and down, and it's going to cause the agitator to oscillate vertically. All right, so that's about all we need to know about this experiment. Make sure you come down into the lab, take a look at it physically for yourself, mess around with the valves, make sure you know what's coming in, what's coming out, and then I'd be happy to take any questions. Okay, as promised, here's our 3D virtual tour of the liquid-liquid extraction experiment number 1, the York-Scheibel column. All right, so first let's focus in on the control panel. Okay, we can see at the bottom of the screen we have a pH display that's going to show the pH of the water coming out of the bottom of the column. We have a pump power and pump speed to control the agitation in the column. And we have flow rates for the water and the MIBK acetic acid mixture. The flow rate of the acetic acid, as we mentioned previously, will be controlled by the pump speed, and that of the water can be controlled by the valve. Okay, as we look down towards the bottom, we can see here's our pump down at the bottom of the column. Also at the bottom of the column, we have our pH probe to sample the water outlet. We have a valve to sample the liquid coming out of the column. Again, the valve shown here, which has the long handle up towards the top of the column, that's the valve that's going to be used in order to change or to control the level of the interface between the aqueous and the organic. Remember, the interface level needs to be maintained between the water inlet, which is shown here, and the organic outlet, which is shown here. As we continue up a little bit higher on the column, we can see the shaft and the motor. So again, we have an O-ring. That O-ring will need to be connected to the motor and to the top of the shaft of the agitator in the column. There are a few other things around the back of the column. In the sake of doing a 3D tour, I'll show you, but nothing that's going to be too terribly interesting in helping you run the column. Okay, so that just about wraps up our 3D tour of the column. it is important for you to make sure you come down to the lab, see where all the lines go, where they come from, what valves you need to change. And then after you're familiar with the experiment, if you still have questions, I'd be happy to answer them.